So hello everyone, today we're going to talk about lists and well, the basics of lists in Scala, like how to declare them, what are the basic functions you're going to need and you're going to most of the time work. So we start with declaring function list, and I'm saying val fruits it's a list, and within parentheses I'm going to give the elements of the list. Basically this makes use of the nice apply method. A list is an object, has an apply method, and this apply method takes any number of arguments of that type. I can give it the optional type, and it's a list of string. So it's a typed string. It's a type list, but because of type inference, you don't have to necessarily declare it there. What else is it interesting about lists is that they are immutable, so you cannot change the values once you declare it. So every function that you might use on this list will always create a new list with the elements being modified by whatever function you're gonna do. So you never modify the original list. It's a very important thing to remember. They are immutable. Also, they're homogeneous, so that means that the list needs to contain the same type of elements all over the list. The next part about lists, for example, you can declare a list of numbers, and you just do the numbers there separated by comma. Yeah, so far so good. I think this is quite a nice way of declaring it. Of course, we have an empty list, and the empty list is actually a list of nothing, and we know that nothing is a subclass of like any other class. It's on the bottom of the list, and you declare it by doing list of parentheses, empty parentheses, and that is an empty list. So an empty list does not mean nil. In here I'm showing how this is equivalent to list.apply, calling the function apply, method apply. You can declare also list of lists, of course. So I'm making a matrix here, and I'm gonna declare it. I'm gonna say it's a list of int, and I'm gonna declare it by just saying list, and within parentheses I'm gonna give 3 lists separated by comma. And your list can be as deep as you want. I wouldn't recommend go too deep into this. It makes no sense, but you can do it if you really want to. And I'm gonna run this and see what it gives me. As you can see, the fruits is a list of string, and because it's an object, also it has this nice toString that will print me all the list elements. Of course, there are other ways of declaring a list and creating lists, and I'm gonna show you in a little bit what they are. But before that, we're gonna say that your lists are covariant. What does it mean? If I have a class A and a class B that extends A, if I have a list of B elements, so I'm saying it's a list of new B and new B, so it's a list of 2 B elements, and then I want to construct a list that accepts A elements, which is the superclass. I can safely say that one equals list 1. So a list of B elements is a list of A elements. Yeah, so that it's a covariant. Subtypes. Okay. And now that we got that one out of the way, we can construct the list also with the help of this cons, which is double column. Basically, all the lists are element cons nil. because nil is the last element of the list, and I'm making a new list called fruity, and I'm inventing some words here. I'm saying appley, bubbly, pearish, and I'm using this cons operator. So that basically concatenates everything, and always at the last you have to say nil. And this is kind of equivalent with putting the parentheses there, because it always evaluates from the end to the beginning. So I will take the first element and concatenate to nil, then the next element from the end, and so on. You shouldn't have to have the parentheses there. So remember, it doesn't not go from the front to the end, but from the end to the front. Okay, so that the first element will be your head. Also, you can construct with the range method, and you give it a range, and it goes from beginning of the range till the end of the range minus 1. So it will never print there 7, but it will start from 1, and by default the increment is 1 when you're talking about integers, right? Now you can always make it so that it goes from 2 into 2, so then it will start with 1, but then the next one will be 3, and then 5, and the 7 will never be printed because it's the last one. So you can give it whatever step you want. I can, for example, make another one that goes downwards, so it goes from 10 to 0, and I'm saying minus 1. So I go from 1 to 1, but downwards, so you can give negative steps as well. This is very useful. I remember in Java I used to construct it with a for loop or something like that. In here this is much easier. You can also construct a range of letters, which is very nice, like characters from A to E, and this letter would just this list will just have elements A, B, C, D, without the last one, always. Now the next thing I was wondering, what happens if I add 1 there or 2. I wanted to see if it skips one letter, but in the end I found out that actually it will use the ASCII characters, the code, numerical code, and will just add 2 to all those codes. So it's strange that it doesn't give me characters, but oh well, it happens. What else do we have besides range? We have a fill function, which is very interesting. For example, if you have the same element all over again, right? Let's say you have the character A, and I want to fill it, I don't know, 2 times. As you can see, this fill has multiple meta signatures, so you can play around with it. I'm just gonna do the easier stuff. I'm gonna fill a list with A's 2 times. So there we go. It's a list of A and A. What happens if I do 2 times 2 times A? So it gives me a list with 2 list elements, and each list element has twice the A. Basically, that's what the ends mean, and you can go till n5. So have a look, play around, you know, it never hurts. You can also not do it just with characters, but with strings and numbers and whatnot. Like for example, I'm gonna use a string hello, and it's gonna make a list with 2 hellos there. Another way to create this list is by using a tabulate function. So the list has a method called tabulate, and it also takes several parameters, but it takes a function as a second parameter. And the function will transform. What will happen is the parameter is the range. So when I say 7, it will start at 0 till 6. And then for each of the numbers from 0 till 6, it will apply the function. If I would give two numbers there, 7 and 2, you will have a function that takes these two ranges from 0 to 6 and from 0 to 2, and you will do stuff with them. So if I'm gonna run this now, you're gonna see a list that actually starts from 0 plus 2 is 2 and 1 plus 2 is 3 and so on. So basically 7 is the end range that you can have, and then the other one is the function that transforms the elements. And yeah, have a look, play around with it. It's a very interesting function to have. Now the last thing that I wanted to show you guys is how to create a list from two lists. So you can concatenate two lists. You have a list of numbers and another list of numbers, and you want to put them together. You have this very interesting construct called a triple column. So I'm saying nums3 is nums, triple column nums2, and what you will see is first the elements of the first list and then the elements of the second list glued together. Always, as always, these operations result in a new list, always. Okay, now we of course have some very used functions, which are head, tail, is empty, and length. So this you're gonna use a lot, especially in pattern matching and so on. And for example, the head will return you the first element of the list. If then you want the tail, it will return you a list, which is all the elements from the list except the head element. You have a is empty, which will return you a boolean, which is true or false depending whether the list is empty or not. Why I'm saying that nil does matter. So if you have one is to have an empty list and one is to have a nil list, and if you do is empty on a nil, you will get an exception. As you can see here, I asked for the head and gave me apples. I asked for the tail of numbers, it gave me all the numbers except the first element. And I'm saying is empty. And now if I'm trying for the empty list is empty, it will return me true because the empty list is empty. And you know, these are your most used functions of all time. And also you have the list.length if you want to know the length of the list. Pretty straightforward, not much to say about it. Like I said, you can do pattern matching. And in pattern matching, you usually want to match a pattern, right? A list, you can match it by its head, by its tail, and you can it's very much used when you want to do recursive functions. And if you want to do recursive function, you always have to first think about what is the end of that recursive function, most probably when your list is empty, because you're always going to recursively apply the function to a smaller subset of the initial list until you have an empty list or you have a one element list. So in here what I'm doing is I'm creating a function called lookup, which will take as a parameter a list, and I want to print every element of this list. And how am I going to do that? I'm gonna say that it doesn't return anything, or returns unit, because you know, as a recursive function you always have to give it a return. And then I'm just doing the normal pattern matching that we learned in the last lessons. So I'm matching this list first with an empty list, and that will be an empty list, and then I'm matching it with an element and an empty. So basically in here I'm saying this match this with the first element of a list, or with one element of a list of one element, because a list of one element says it's actually x cons nil. And this kind of construct is equivalent if you say xs.head. It's kind of the same thing, doesn't matter, but I want to make it explicit that is one list element. And then I can have a head and a tail, right? Doesn't matter. And this will be my I'm gonna print the head, and I'm gonna call recursive the lookup with the tail. So I'm gonna recursively say tail, and then I'm gonna print the head. Okay, and I'm gonna see if this thing compiles, and it does. So I can call it with something else. What I wanted to say is that you can always match a list. For example, if you say it has to have at least two elements, then I'm gonna say x cons y, that's the least two elements, and then a tail, and that tail can be either an empty list, right? It can have two elements, or it can be more, but then it won't match anything that only has one element. So you can do a lot of case matching, or even match directly on elements of the list. So I'm gonna call the lookup with the numbers, and it should print me all the elements of the list. Okay. Now you might wonder why they didn't print the empty list. That is because on the case x and nil I forgot to call. Oh well, I actually never call the empty list case. I don't do a recursive call, so I made a mistake there, but it's a bit too late to rectify. You have some other functions called init, last, and reverse. And init is a very interesting function because it returns you a list that contains all the elements except the last element. The last will return you the last element, and reverse will return you a new list that has all the elements in reverse. So that is very nice and very interesting. Now we have a few more functions that maybe you're not going to use them that much, but it's nice to know that they're there. Is take, drop, and split at. And for example, you can, I'm gonna show you now another way of writing this without a dot. So you say list and then a space and then a function and then a space and then a parameter. So that is like again a syntactic sugar, and sometimes you will see it that people prefer not to write a dot there. This helps you also write very, how to say, expression nice constructs when your functions look like the verbs and so on. So what does fruit take to? Takes the first two elements of the list and returns a new list with that one. Fruits drop to, it drops the first two elements of the list, and the new list that is created is only with the last elements of the list after the first two. The split at two will actually result in a tuple of two lists that will have the first list, the first two elements, and the last list is the remaining two elements. So we're not talking about indices here, but you will talk about number of elements and where to split it, or after which element it will split or it will cut. But a part that is not always used is actually the lists have indices, right? And you can print them I mean, you can find out what the indexes are by doing, you know, list.indices, and it returns you a range, which is also part of the collections. We're going to talk about it later, but it's a range from 0 to 4, and this is how you find out that actually list indexes start from 0, and because the range starts from 0. You can also call, for example, fruits with index 2, and it will give you the element that is found at the index 2, but in this case is the third element of the list, because as we saw, it starts from 0. Another interesting function is flatten. For example, we had that matrix up there defined, and I want all the elements to become elements of one single list. So how would you do that? Normally you would traverse the matrix, and then you would add every element to a resulting list, but in here you have a flatten function that will just do that for you. So if I'm gonna say flatten there, and I'm gonna run that one, it will result me into a list that contains all the elements of that initial matrix. Okay, now one last function that actually is very useful is zipping. Zipping, let's say you have two lists, both of the same type of elements, but it's not necessarily that it is the same type of elements. It can be different type of elements, and if you say zip, and I'm choosing now a list that has, first of all, you know, lesser elements than the second list. When you do zip, it will create a list that contains tuples with match, you know, the elements of the same indexes together. So the elements of index 0 in list number 1 matched with elements index 0 list number 2, and so on. Once the first list finishes, you know, the elements of the second list are discarded. So you will end up with a list, but that can have the that has the same length as the first list, as the initial list, not as the second list. And as you can see here, it creates a list of tuples. Now you can unzip this to create your two lists again, but just a reminder, you can never get back to the num3 list that had more elements, because those ones are lost. So whenever you're doing unzip, you're gonna end up with a two lists of the same number of elements. And that is a very good distinction to make and to remember. So what else do we have? I think we have now the most fun one that I find is how to make a string with your list. So make string function takes three parameters: a starting character, a separator, and an end character. So if I have my my list of numbers, and I can print them, I can make a string that contains these square brackets, and then all the numbers in the list separated by comma. And this is very nice function to use when you want to do two strings and all kind of stuff with your lists. Now I'm gonna delete all that part because I don't want it to compile every time, since we've covered it, and we're gonna go into functions that actually are higher order functions on the list. And why are they higher order functions? Because they are accepting as a parameter, as an argument, a function. So what you're doing is you traverse the list, and you're applying a function to each element of the list, and the result can be another list that has all the elements constructed from the previous list elements plus the function. So the first one we're going to talk about is map, and map is a very useful function because it will always return you the same list with the same number of arguments. And I'm mapping it to a function that will add 1 to each element of the list, and you do it with anonymous functions there, of course, but you don't have to necessarily declare it like that. You can do it easily if you just put an underscore, because we only have one element right at a time. You don't have to, it's very easy to do that. Underscore plus 1, and sometimes you'll see this notation, and so you know it exists and you don't get any surprises there, and so on. And you can apply, you know, any function that you want to this one. For example, fruits, I'm gonna map it, and I'm gonna construct a list that actually contains the length of the elements. So you can construct a list of the length of those strings. So you don't have to construct the list resulting doesn't have to have the same type of the list, the initial list. Okay, that was map. You can do, of course, a lot of crazy stuff. You also have a flat map. And what does a flat map mean? Like if I want to map all the strings there, if I would do map and then underscore to list, what will happen is every string in that first initial list will be transformed in a list of characters. So I will end up with a list of lists, but I don't want a list of lists. I want an entire list that contains all the characters. So then I do flat map. So it will be just like a map and then a flatten at the end. And this is what you get result. Now the next one that I wanted to talk about was the for each. And for each basically just applies a function for each element of the list, and it's very useful. For example, when you want to have a sum, I didn't talk about for each. I forgot about it. I was really hoping I will talk about it, but anyway, filter. Filter is another function that also takes a function as an argument, but it's a special function because it's a predicate. That means it returns true or false if a condition regarding the element is true or false. So I can filter the fruits of the length that is equal to 4. I can partition the fruits, the numbers for what does partition mean? It will split in two lists, one that has the even and one that has the odd numbers, because that's what my predicate checks. My predicate checks whether this particular element %2 is equals to 0. There another function that takes a predicate is find, so it will find me the first element that is with that condition. So the first element that has the length 5 or 6. As you notice, we have more elements of a length 6, so it won't return you all the elements of length 6, but only the first element that it finds with length 6, and in this case it's apples. And actually it will return you an option of string, and option can be none if it didn't find anything, or it can be sum of that function, of that element. Yeah, and we're gonna talk about options a bit later on, but just so you know, it's just an option because it always can be that it returns nothing, but in Scala nothing, it's nice to say with none rather than nil. We also have a drop while function, and take while, and this ones will just drop elements until that condition applies. So if I'm gonna say drop until you find the first element that does not um, validate that condition, I'm gonna say drop while percentage 2 equals 1. So then we will drop just the first element, because the first element is okay with that condition. Of course, there are more functions for the lists, and I urge you all to have a look at them and play with them, and also leave a comment on the blog about this, and if you have any questions. Thanks for watching.